Here are 18 pages of questions which are designed to help you improve your maths, revise your maths, learn your maths, whatever, if you're already a fairly advanced student-ish. They're designed to be creative, so not generally too much working, but I've tried to make them kind of test how well you understand maths. Um, all the way through, I'm going to go really fast, so just pause the video to give yourself thinking time. Especially, I think you should probably have a go at the questions before me, so pause it, have a go, then watch my answer. Okay, well, I know that root 9 is 3, so I'll just change the order to make it look nicer. Done. Okay, how am I'm going to try and make the left-hand side look the same as the right-hand side. Oh, I've spied something. That's 2 squared, and that's 2 cubed. So now I've got something that looks kind of the same. So 2 to the 3x equals 2 squared. So now I can say by inspection, 3x must be equal to 2, because there's an equal sign there, and they're the only two things that are different. So x equals 2/3. You might have worked it out a different way. That's how I decided to do it on that occasion. I love this question. It's incredible how many of my students can't answer this, and it's just because of the way this topic's taught. There you go, that's a perpendicular line that isn't a bisector. I think we're so used to drawing something that is a bisector, because that one is a bisector, that we kind of forget what one that isn't a bisector. So I could have drawn the one that isn't anywhere as long as it's not in the middle, because bisector means it's exactly in the middle, bisecting it, secting it into two. It's a fraction. It's 1/5 divided by 7. Maybe you couldn't read it. I'll give you another chance. I'm just going to times the top and bottom by the same number because I can know that. I know I can do that when I'm rearranging or manipulating fractions. So that gives me 1 divided by 35. There you go. That'll do. Can't simplify any further. Oh, we've got 4 things to simplify here. Oh, look. What's x minus x? That's just 0. So that's 0. If I inverse something and inverse it again, I get back to where I started. That's just 2x cubed, which I'm going to simplify to say 8x cubed. And this one is just x to the 9, because 3 squared is 9. You might not have understood this one if you didn't quite, you might not have quite understood the last one if you didn't quite read my writing properly, but the idea was this 3 squared was in the power of x. Okay, you might have struggled with this for a bit. I remember the first time I saw this a long time ago, I struggled with it. That means x to the 9 equals minus 1. So that means that x equals the 9th root of minus 1, which is just minus 1, because minus 1 times minus 1 times minus 1 9 times makes minus 1. That's it. What is x? Oh, well, I'll just times both sides by 5, and I end up with x equals 7. There's another way of doing this one, which is I could have just said by inspection. Let's just write that down again because I really do like this. I think it's inspection. I think it's a very powerful maths technique. So by inspection, x equals 7, because everything else in the equation is the same and it has to be true. I'm just going to go back one. Do you remember this one? What if the question was x to the 8 plus 1 equals 0? Do you want to have a go at that one? Because it's occurred to me that there's a little extra teaching point here. That means x to the 8 equals minus 1, which means there is no solution. Why? Because if it's an even power, it can't make a negative number. So this crucially had to be an odd number for the question to work. Anyway, let's have a look at the next question. I'll just clarify what this question means in case, because this is unusual. If you're a regular student of mine, you'll know what it means probably. Would you sketch or solve these? So in each of these 3 situations, do you think the question is sketch this or solve this? And in either case, maybe have a go. I think the first one is just saying sketch it, and that would look like that, passing through minus 4, because it's just y equals a function of x. The next one, I'm thinking that just means solve. I'm going to move that to the right and then move that to the left. So I end up with 10 equals, I'm minusing x from both sides, so 4x. So x equals 10 over 4, which equals 5 over 2. That will do as an answer. This last one, I'm going to rearrange it. So it becomes y equals, well, let's just add 5 to both sides, just to make it clear. So that means that x plus 5 equals y, and then I will always do this. I'm going to rearrange it to say y equals x plus 5, and then I'm going to sketch it, because I just want there to be like minimal risk that I get confused because it looks unusual. I'd rather just make it look like something I'm familiar with. And I'm being so lazy here, but I guess what I should definitely have done is I should have labelled my axes and put a 0, and I should have done it here as well. Let's go on to the next question. Ooh, what about this one? It's a quadratic, so I'm just going to factorize it. So I'm going to go root 27x minus root 8. I'm just going to finish this before I talk about it. Root 27x plus root 8. Sorry, my writing's gone a bit wonky here. That's difference of two squares. Now I know that 8 is not a square number and 27 is not a square number, so I've had to use thirds. So now that tells me that x equals the square root. Well, let's do this properly. So that means that root 27x minus root 8 equals 0. So I'm going to add root 8 to both sides. So that means that root 27x equals root 8. And then divide both sides by the square root of 27. There we go. And then the other side, do the same thing. You end up with x equals minus the square root. I'm going to call this a little bit of a trick question, because we're so used to, in exams or in maths questions in general at this kind of level, oh, if there's an 8 and a 27, that probably means like cube rooting. Because they often give me numbers that are just convenient and nice. Well, do you know what? In this case, I didn't make the question like that. It was a bit of a red herring. We had to kind of just think, whatever, I'm just going to think about that as, I don't know, B, and I'll think about that as A. Or I might even just ignore them completely. What would I do if it was just a 1 there and nothing in front of the x? Oh, that's what I'd do. So what would I do if it was an a and b? Oh, I'd still do difference of two squares. Oh, so I still do difference of two squares, just looks a bit awkward. Let's do the next question. Right, well this one is just, that cancels with that, that cancels with that, that cancels with that. And if you're cancelling, dividing or cancelling timesing, you would get left with a 1. So that equals 1. Okay, there's 3 things to do. This index is giving me 3 things to do. First of all, I'm going to turn it upside down first, so I'll deal with this one first. So that'll be 9 over 4 to the 3 over 2. I'm going to deal with this one next. Come to square root. I'd rather make the numbers smaller first and then make them bigger later, because I reckon that's easier. I'm dealing with generally smaller numbers. So then that is 27 over 8. Let's do the next one. Oh, I like this question. Factorize if possible. Let's have a look at this. Well, this is difference of two squares because there's a minus sign in the middle. This one, oh, that'll be x plus 3, x plus 3. This one will be x minus 3, x minus 3. Whoops. And this one is not possible. Factorize fully. Okay, if you're familiar with the way I factorize, the first thing is I deal with this. I need something times something that equals that whole thing. 17 is a prime number, so it's assuming it factorizes, and the question implies it does, it's going to have to be 17x times x, I guess, unless it's some weird square root thing, but I can't see any square roots anywhere else. And then the second thing is I deal with this. That's the second thing I do. Well, there's only one way of making 1. Well, should we multiply out and check it works? Oh yeah, it does. Brilliant. There we go. That's the answer. Whoa. Don't ask the question. Okay, this is part of what I call Zen Maths. I sometimes have little moments with my students where I go, let's do some Zen Maths. Okay, so what do I mean by saying don't answer the question? What I mean is just look for information. So that's the first thing you do. You look for information in the question. So we see a question, maths question, and we go, I'm not going to try and answer it. I'm just going to look for some information. Then I'll make an equation, or maybe more than one equation. And then the third thing is, I'll just solve those equations. And then if you do that in that sequence, you're probably going to get the answer. Do I really mean don't answer the question? Well, I'm trying to be zen, so it's like, well, I mean what I mean. I'm trying to give you an idea. This is a way of approaching things. If you're looking at a question, you're like, I've got no idea what to do, maybe try this approach. Let's look at the next page. Oh, this is a properly weird question. Maybe if you struggled with it and you've unpaused it, maybe have another go and maybe think about that Zen thing we just looked at. Oh, well, if I don't understand the question, can I just see something to do and just try it? Okay, well, I've spotted something to do. I'm going to try factorising, because why not? It looks like something that could be factorised, and maybe it will help because it's an equation. So P, I've got to now make 9q squared, because I've done that first. I'm going to do this second. Oh, well, that would be 3q, and that would be 3q. Does that make the middle bit? Double check it. Oh, it does. Okay, so that's worked. Wait a sec. They're the same, so I only have to do one of them to be equal to 0. So P plus 3q equals 0, which means that P equals minus 3q. Oh, look, I've just done it. I've just made P the subject. Victory for Zen Maths. Colour in where this curve is greater than 2. Well, I'm just going to do it. There we go. In case you're thinking, I know that when I was younger, first learning maths, this really bugged me. I'm like, well, how do I know I'm not supposed to colour in that bit? The answer is, I would say, convention is just kind of what mathematicians mean when they say that. They mean for the vertical y-axis. You just kind of get used to what people mean. Okay, we've got to show algebraically that the sum of any three consecutive even numbers is a multiple of 2. So, oh, they mean even numbers? So 2n would be an even number. Then let's add on the next even number, which will be 2n plus 2, because that's the next even number. And then the next even number will be 2n plus 4. So that makes 6n plus 6, because I can ignore the brackets because it's all plus signs, only plus signs, which is 6 times n plus 1. Oh, which is a multiple of 6. This is the last question. What can we say about A, B and C? Well, we can say that either A or B or C equals 0. And if you want to get technical, you could kind of put in brackets, and it's possible that more than one of them is equal to 0. Hopefully you found some useful questions in there to help you with your maths learning.